going to quickly share what Provably does for as a verifiable database infrastructure. We focus mainly on two use cases, which is verifiable database infrastructure for AI and blockchains. And essentially, it's a middleware that you can connect to a database like a blockchain or relational database or a tabular structure. The idea is that you can download this open source tool from the middle of March 2025, and within like 20 minutes, you can configure the middleware, connect to some database, and you can start to run remote queries on it. You can run queries on it and prove to someone else that your infrastructure ran correctly and completely, and therefore they can rely on that answer, right? And very specifically, they send in a SQL query. Some external party sends in a SQL query, and the compute runs correctly and completely on this database. We obviously prove the correctness and completeness of that, whatever type of database it is, and then we give back the answer and the proof. Now, in Provably V2, which we release in the middle of April, we are supporting relational databases like Postgres, MySQL, and SQLite, but we built it in a modular fashion so that the ambition is to be able to produce proofs on different types of tabular structures. So it could be like databases like Redis or vector databases or blockchains, NoSQL databases, etc. And I think that's how this type of modularity is how we can get verifiability on all types of databases to meet different needs. Because just the nature of computing is that you need different types of databases. And then the idea is also to support not just SQL, but to support different types of query languages as well. Now, as a middleware, the core ZK module is this, but what you can do from an AI perspective is allow an AI model which has its own data pipelines for what we talk to AI about what it thinks, what could be the potential answer, which is the RAG phase, and then the actual computation, if there's any database involved. We can start to prove the correctness of all of that. And essentially, Provably is a middleware for AI data pipelines. So when a user asks a question, we can understand with proofs what it really, which context it took, what were all the things it considered, and then the correctness of the answers that comes back if there's some database involved. So it comes back with an answer and a proof. And I'm going to show you that demo in just a second. On blockchains have verifiable data within the nodes, and there are all of these other people that want to do some compute or to make some decisions like smart contracts, AI, machine learning, etc. The problem is that they only get a small amount of data from blockchain nodes themselves. Most of the time when they're making decisions and they're doing analytics, this data is replicated to another environment like a database where this type of credit scoring happens, or yield optimization, or flash loan monitoring, whatever. And when you replicate verifiable data to another off-chain environment, you usually lose the verifiability of that data. And then any computation that's done here is also not verifiable. Because other than us, there's almost like next to no method out there for verifying the correctness of these computations, which means we are opening ourselves to attacks. And the other thing is the nodes themselves are missing out on providing this valuable service to all these parties, right? So they're missing out on monetization, and generally they're just being not so useful, and things are just like unnecessarily complex. So what we are providing with this verifiable data compute is that this is a module that can be integrated to some decentralized database or a blockchain node directly at the node level, and the node operator can set a price for per query, so they do get paid, and then they can monetize the big data that they have themselves. And therefore, somebody on this side can ask one node a question, or we're going towards supporting distributed verifiable queries. And for that, we are planning to incorporate Apache Spark this year. And therefore, a party on this side can send in a question, and we use a combination of Apache as well as AI to basically figure out where is the most relevant answer, and then to run those computations locally, and then to bring it all back so that the person on this side has analytics or some big data compute with proofs regardless of where it comes from, right? So essentially you're doing some on-chain big data compute, but then you're also doing it in a distributed way, which means different nodes are producing local compute, and then we're able to put it all together and serve the end user. Now, going to the demo, the middleware has three parts. When you once you deploy the middleware, you can configure it, and then you can connect to some local data source. So it's super simple to connect to a local data source. You just put in the username, password of your database, or if you're connecting to a blockchain, well, actually, it's kind of like similar as well, because blockchain nodes have databases as well. And then what you can do is decide what data you want to make available and to whom. So in this case, I'm accessing someone else's live basketball data because they've made it available in a public network. There's also some ongoing financial data that was last updated. You can see in February, I believe that one. And I'm now running analytics on someone else's data. There's also, you can form your own data DAO so that you're only sharing data within the network, and then you can even set price per queries and so on. Now, I'm going to run some queries on basketball data, and this is a very AI-friendly data catalog. If you don't have this AI-friendly data catalog, AI doesn't even know you have the data, and it doesn't know how to ask questions on that database as well. So here, there's someone has provided basketball coaches as a data set, and here's all the columns that they've made available. They've provided the descriptions, and I can ask a SQL query, like I can go here and I can say how many coaches are there, name, and then I can do count, right? And in this version 1, there was only like a handful of queries that we could run, like sum, count ID, average, min, max, and so on. I'll tell you what we're doing next, but essentially you run this query, and it's saying that there are 433 basketball coaches out there, and it's produced a proof which we can verify the correctness of. But now what I can do is also use AI to talk to that collection of data, and I'm going to ask this first question, and I'm going to ask without the proofs with the proofs off, which is how many basketball coaches are there, and it's obviously figured out that the answer is in basketball coaches table. It's run a query on that outsourced database, and it's telling me the answer is 433. Now, we know that the answer is correct because we ran it just now, but how do we know the AI answer is correct? So we can ask it to produce a ZK proof, and it's just quickly doing that, and there you go. It took a few seconds there to produce the proofs, and if I click on that, it tells me that in this whole answer, this is the one part that is verifiable. I'm going to click on that, and it tells me here's a SQL query that that AI wrote. So it wrote select count ID from coaches and the query ran correctly and completely because there's a proof, and here's a query result, and it also gives me an explanation of the query that it ran. And the proof is proving two things. It's proving that the maths on this count ID ran correctly, and then it's proving that from the coaches table or for this query, all the relevant data pertaining to that query was included by the system. To make that more clear, I'm going to ask another question. How many basketball coaches are there from USA? And this time I'm going to leave ZK proving on, and it's produced the proof straight away because it's a very small amount of data. It's 170 rows in a database. And here it's proving that AI wrote select count ID from coaches where country name equals USA. It's proving that this maths is correct, count ran correctly, and it's complete because it only included where the country name is USA from coaches, right? And this is essentially this is like in a nutshell, very simple verifiable SQL. What we've been doing is making the process of producing proofs really fast on big data, like millions of rows, and we're also starting to support more sophisticated SQL queries. And the goal is that in this kind of April release, that we're able to do 5 million rows and proving is less than 7 seconds, very fast verification, and then we're getting towards a massive amount of data and proving is really fast with or without GPUs. With GPUs, we're like down to milliseconds. I hope that gives you an idea that when AI gives you an answer on some database, we can start to prove the correctness of it. And yeah, thanks for watching.